Okay, good morning. Good morning. Today we're gonna be dealing with building science N2. We're gonna be dealing with a beam. So in this case, we are given a beam. It's like this. This is our beam. So on our beam, we are given 2 kilonewton as our overhang this side, and then 4 kilonewton as our overhang this side. And then from there, we are given a UDL of 3 kilonewton per moment, which takes up to 2 meter. It's a 3 kilonewton per moment, which takes up to 2 meter. Then the first thing that we do, we have to convert our UDL into a downward force, whereby we are going to say the force multiplied by the distance, force multiplied by our distance. Our force is 3, our distance is 2, which is going to be 6 kilonewton. Then from there, we go to the center of our UDL. When we get to the center of our UDL, we make a straight downward force, which is going to be 6 kilonewton. And then now we divide the distance into 2, from 2 meter to 1 meter, 1 meter, right? Then from there, what do? We start calculating. We can start with RL, the direction of RL. Remember, at the end of our calculations, the upward forces has to be equal to the downward force, whereby we have to say upward is equals to downward, which means the summation of RL plus RR has to be equals to the summation of all the downward forces, which is going to be 2 plus 6 plus 4, right? Sure. Then from there, what I'm going to start with, RL, which means I'm going to say RL going towards RR, which is going to be something like this, which is clockwise direction, which is RL. Then I do what? Clockwise movement equals to anti-clockwise movement, right? Then from there, I start RL multiplied by the distance it takes from where RL is up to RR, which is going to be 2, 4, 6, right? Multiplied by 6. And then plus our overhang. We have an overhang that side. Remember, all the forces are moving towards RR. So which means in this case, what we're going to do, this overhang, it is coming to RR. So which is going to be 4 multiplied by the distance it takes from the force to the RR, which is going to be 2. Then which is equals to, because it's only one overhang that side. Then from here, what are we going to do? We're going to check. We have 6 kilonewton, right? And then we have 2 kilonewton. You can start with any of the two. It's not a big deal. I prefer to start with 6, right? If I start with 6, remember all the forces are moving towards RR. So which means it's going to be 6 multiplied by the distance it takes from where 6 is up to RR, which is going to be 1 plus 2, which is 3, right? Plus the last force, which is 2. I'm going to say 2 multiplied by the distance it takes from where 2 is up to RR, because all the forces are moving towards RR. So I'm going to have 1, 3, 4, 5, 6, 7, which is multiplied by 7, right? Then from there, what do? We're going to say RL multiplied by 6 is going to be 6RL plus 4 multiplied by 2. 4 multiplied by 2 is 8, right? Which is equal to 6 multiplied by 3. And then 2 multiplied by 7. Right? Then from there, what do? This side is still the same. 6RL plus 8 is equal to this side. We're going to say 18, 14, right? 18, 14, what are we having? We have 0, left with 2, right? What are we doing? We're saying 18, and then we have 14, right? What do we do now? This becomes 12, this side, right? This becomes 12. Am I wrong? If it becomes 12, we say 2, 1. Then we have 32, right? Because this is going to be 3. Sharp. Then from there, what do? You're going to say, we take this one to that side, we collect the like terms, right? So we're going to say 6RL is equals to 32 minus 8. It has to change the sign. Remember, when it moves towards that other side, whenever it crosses the equal sign, it has to change the sign. Then from here, what are we going to do now? We are going to say 32 minus 8. 32 minus 8, what are we going to have? We're going to say 6 RL is equals to 32 minus 8. We are going to have 24, right? Then from here, what do? We have to divide here so that we can make RL subject of the formula. So we are going to say 6 RL divided by 6, and then this side 24 divided by 6, and then what do we do there? What do we do? 6 RL divided by 6 RL divided by 6, it's RL, and then 24 divided by 6. What are we having? 24 divided by 6, is it not 4? Because this one cancels this one, and then we are left with RL is equals to 24 divided by 6, it's 4 kilonewton, right? So which means now we know that our RL is 4 kilonewton. Our RL is equals to 4 kilonewton, right? Then from there, this one's, let me put it the way it was. Here we had RR, right? Sharp. Then from here, once we know that our RL is equals to 4 kilonewton, what are we going to do now? We have now to calculate the value of RR. The value of RR, this is what we are going to do. Now we are going to say anti-clockwise, which is RR, right? Which is anti-clockwise movement equals to clockwise movement. Now we are going towards this direction. Now we are moving from RR to RL, right? So we're going to say RR multiplied by the distance it takes from where RR is to RL, which is 2, 4, 6, still the same, 6, right? Plus we have an overhang this side, right? Which is going to be 2 multiplied by 1. Are we clear on this one? Which is only 1 overhead. Then from there we say equals to, we are left with 2 forces, which is 6 kilonewton and 4 kilonewton. Both those forces are moving towards RL, right? So which means we are going to say 6 multiplied by the distance it takes from where 6 is up to RL, which is 1, 2, 3. It's going to be multiplied by 3. And then plus the last force, it is 4. So you're going to say 4 multiplied by 2, 4, 6, 8. 4 multiplied by 8, right? Are we good? Then from here, what are we going to do? We have to calculate here. So what do we do there? We are going to say 6 multiplied by RR, which is 6. And then from there, what are you having? What are you having? Again, you're going to come by, you say 6 RR plus 2 multiplied by 1 is 2, which is equal to 6 by 3, 18, plus 4 by 8, 16, 32, right? Then from here, what do you do? From here, what do you do? We have to add this ones, right? Which is 6 RR plus 2 is equals to 18, 32, 0, which is going to be what? 50. We have 50 completely, direct 50, right? Then from here, what do you do? This one has to go that side. It has to change the sign. So we're going to say 6 by RR is equals to 50 minus 2. 6 RR is equals to 48, right? 6 RR is equals to 48. Then you are going to say what there? We have to make a RR subject of the formula. We have to make RR subject of the formula. If we are to make RR subject of the formula, what are we going to do? We are going to say 6 RR divided by 6 is equals to 48 divided by 6, right? Then from there, this one cancels this one, then you're left with RR is equals to 48 by 6, it's 8 kilonewton. Therefore, you come by, you indicate here in your RR is 8 kilonewton, right? Then from here, last step, whereby they say test check your answer or prove your answer, you are going to say upward is equals to downward, whereby you're going to say RL plus RR is equals to downward force, whereby the RL is equals to 4. You're going to say 4 plus RR 8 is equals to the downward force, which is 2 plus 6 plus 4, right? 4 plus 8 is 12 kilonewton, which is equals to 10 2 and then 12 kilonewton. Therefore upward is equals to downward. That's it. All the best. Thank you for your time.